Alright, good stuff today. We are going to talk about prime factorization. And this is kind of the keystone to be able to go from here to ultimately what we get into is factoring trinomials, and that's coming up. The first thing I want to talk about is what does it mean to be a prime number. The definition of a prime number is that the number is only divisible by 1 in itself. So the short list of prime numbers is 2, 3, 5, 7, 11, and so on. The idea being that 4 can't be prime because it's divisible by 2, 6 can't be prime because it's divisible by 2 or 3. And that leads to the fundamental theorem of arithmetic, which is that every number has a unique prime factorization. So I want to start today's lesson by talking about how we're going to factor a number. So let's take 56. When we talk about prime factoring a number, what we're really talking about is getting it to its most simplistic form. So we have to take a number like 56 and ask ourselves, what is a factor of 56? Well, it being an even number, that's fairly straightforward. It's 2, and 2 times 28. And you can use a calculator, so it's not necessarily you have to have a good number theory here. 28 is also even, so it's divisible by 2. 14 is 2 times 7. And so we have 3 2's and a 7. So what we really have is 2 cubed times 7. That is the prime factorization of the number 56. A couple more examples just to make sure we got the idea. If we had, say, 140, we would again start with 2, and then again 2. 35, 2 is not a factor, but I believe 5 goes into 35 7 times. And then once you have all prime factors here, you finish factoring a number. So we have 2 squared times 5 times 7. One more. New Orleans area code, 504. Well, pretty quickly you should say 2, and it's 2 times 2, 52, which is also even. So 2 times 126, which is 2 times 63, I believe. 63 is factorable into 7 times 9. 9 is 3 times 3, so we would have 2 cubed, 3 squared times 7, and that is how you prime factor a number. So for a number to be a factor, if you have 2 different numbers that we're factoring, and they each have a common integer, we will call that a common factor. And after you prime factor, what you're looking for when you're trying to find a greatest common factor, so we call that the GCF. So if you have 2 different terms, we're going to factor them out, and we're going to look for what the common factors is. And what you're looking for is a common base with the maximum number of common exponents. Excuse me. I think we're going to have to look at a few examples to kind of get a handle on it. But the idea now is that we are going to look for the greatest common factor of 2 numbers. We're going to start with 12 and 16. 12 we can see is 2 times 6, which is 2 times 3. So 2 squared times 3 to the first power. And 16 is 2 times 8. 8 is 2 times 4. 4 is 2 times 2, or 2 cubed. So again, we're looking for a common base. Remember, we talk about a base and an exponent. The only common base that I see here is the 2, because 3 is not common to both 12 and 16's prime factorization. And we're looking for the maximum number of times that a 2 occurs in each factorization. So in other words, there are 2 2's here, and there are 3 2's here. What is the maximum number of times that they occur total between the both? Well, that would be 2, which means the GCF is 4. So we're looking for the maximum number of exponents that occurs that is true to both, that is the intersection of both factorizations. So let's do some more, make sure we got a handle on this. So let's try 40 and 150. 2 times 20, 2 times 10, 2 times 5. So the prime factorization of 40 is 2 cubed times 5. 150 is 2 times 75, 3 times 25, and 25 is 5 times 5, so we have 2 times 3 times 5 squared. So we ask ourselves, what are the bases we have in common? I think that's 2 and 5. But the most number of times the 2 occurs in both, since it's 1 here and 3 here, is 1, and with 5 is also 1. So we're going to say 2 times 5, or 10, is the GCF, the greatest common factor between 40 and 150. And we can introduce exponents and variables into this, and that's really easy. Like, for example, if we had x cubed and x to the 7th, what is the greatest number that occurs in both? X cubed. Then we mix it up and we start putting in coefficients along with variables. Again, 10 is 2 times 5. 70 is 2 times 35, which is 5 times 7. The things that you have in common are 2 and 5, so we're looking at 2 times 5 is 10. What is the most number of x's that occur in both? I believe that's going to be 2, because we have 2 and 3. And y's, we have 3 and 1, so 1 is the most number of times it occurs in both. And that's it. You can also have the GCF of 3 numbers. 16, we did this one already, is 2 to the 4th power. 24 is 2 cubed times 3. And 30 is going to be 2 times 3 times 5. So look at the bases. What is the only base they have in common? I believe it's a 2. The most number of times it occurs? Once. 2 is the GCF between 16, 24, and 30. Alright, from here we'll go on. Thanks.